All right, so yesterday we had completed a problem. Yes.
Can you give us a definition? Because some of them were.
Okay. I haven't formally assigned it yet, so remind me another time, all right? Okay. So yesterday we solved a problem dealing with what? It's labeled in joules. It's work. Okay. Now, there's 3 variables in the work formula. So you have to know 2 of them to solve for work. But what are your 3 variables? Force times distance gives you an amount of work measured in joules. That's right. You know what? It's the heater just kicked in. But you know why that happened, right? Right, because science is cool. So it's cool in here, so the heat's kicking in. Yeah. Well, it's just as good an explanation as any, right? Right. Okay. Now I noticed if some of you guys, you ladies haven't started yet, okay? But gentlemen, if you are a pumpkin pusher, what are you called? What does that mean? Pumpkin pusher. You play basketball. Who said basketball? Okay. Are you looking forward to your pumpkin pushing sessions this fall? Or this winter, sorry.
Excuse me?
Am I in the way?
Yes.
Okay. All right, so whether it's in basketball, volleyball, okay, let's continue to move forward as a team.
You should be a basketball coach.
No. I know they are.
Why don't you want to?
Because if we don't listen to me in here, who's going to listen to me out there? Yeah. Perfect. You couldn't have done that any better. I mean, you knocked that out of the park. Okay. Which reminds me, Atlanta or Houston? Who are we polling for? Well, they do, but yeah. But Odorizzi pitches for them. He used to be a Twin. But yes, I wanted Atlanta too. All right. That's true. Now he's playing well. All right. So as a review, what's this variable probably measured in?
Force and distance.
Sorry. Meters. This one. And that one. Must be worth a lot of money if it has a lot of joules in it. Yeah. A lot of joules. Yeah. Come on, that was funny. Okay. So if you wanted to measure how much work is getting done or how efficient it is, you're probably going to be measuring this, power. Okay? When you are measuring for power, you want to know how efficiently that work is getting done. and I don't know if it's still true with power tools. It probably is. They're going to have a power rating on them. And that power is measured in what we call watts. Okay? So, well, yeah, but I think watts is a more accepted value for measuring power. Okay? So, how many, see, in my case, I'm a wannabe carpenter. What does that mean? I'm not, I enjoy doing it, the carpentry, but I might not be the best at it. So when I say wannabe, if I had a tool belt on there, someone might say, look at him, he's really handy because he's got a tool belt on. Okay? Just because you look like that doesn't necessarily make you a handyman. Okay? Just because you wear a uniform does not mean you serve with honor either. Okay? Has anyone ever heard that before? Benedict Arnold, he wore a uniform. What about Benedict Arnold? He switched sides, didn't he? Okay. What about Colonel Vindman, maybe? Who's Colonel Vindman? He was an ambassador over in Ukraine. And there's one more, Sergeant whatever. He was held over in Afghanistan for a long time. But again, just because you wear a uniform doesn't mean you serve with honor either. Because, but that's neither here nor there. Valor, yes. Okay. So with that, if you're doing carpentry work, okay, if you are cutting with a skill saw, typically what do you, yeah, I understand you're cutting lumber, but when we talk about skill saws, there's only probably two types. Okay, circular, and one of them is battery powered, the other one's electric. Okay? We're talking about skill saws, not sawzalls.
One of them is battery, one of them is corded. They're both electric.
Well, they run by electric, but my point is you can use that battery powered. One's going to have more power. That's right.
The one that's plugged into the wall has more power, but the other one is easier to get around.
Exactly right. Okay? So, if you are perhaps a framing carpenter, which maybe means you need to put posts in the ground, you probably will use a power rating much more than just that of a battery-powered saw. So you might be concerned about the power rating that that saw has when you purchase it. So there's a rhyme and reason why you purchase different types of tools. Okay? So how many, do we have any, because there's a problem behind here that deals with a, you could say a fishing boat or whatnot. How many of you actually do go fishing on a boat or use a boat over the summertime for recreational purposes? Okay? But what's the difference? Outboard motor, does that mean it's one that you actually steer? It's outside the boat, it's behind it. So what's an inboard motor? Educate me.
So there's a big box on the back end of the boat, and then the motor's inside of it.
Does that have more power than the outboard motors?
It's the same.
It's the same. It's just in the engine is in the boat. The outboard.
I would believe that the inboard engine or motor is probably a lot more expensive than the outboard.
I agree.
Okay?
I second that.
But
All those in favor say aye.
answer that question. Is that more expensive? I would be led to believe so too. All right. So when we are measuring power, we're not worried about that right now. Okay. Notice it's the amount of work divided by time. You want to know how efficiently that is getting done. That is in very essence of what power is. How quickly or how efficiently are you getting that work done? Let's see here. So with that, okay, so with that, here is that problem. We'll talk about that in a moment. Good question.
Power's the same, isn't it?
Repeat that.
Work and power's the same.
No. Power is just how quickly or efficiently the work is getting done because it has time in it. I'll show you that. Okay, some of you might be looking at a glare on here, but it says the motor of a boat can move the object from one side of the lake to the other in 5 minutes. Well, why do we get this number here? I think that number is incorrect.
Let me drive the boat.
Don't put 600 down there. I did that in my head.
600 seconds?
I can't even see it.
Agreed.
300. I put the wrong number up there. Sorry. 300 seconds. Okay? Because how many seconds are in a minute?
60.
Okay? So if we have 5 minutes, you take that times 60 for 60 seconds.
You get 30, then you add your zeros.
That's right. Okay? So in 300 seconds or 5 minutes. But which number would you use? How do we measure velocity? In meters per second or meters per minute?
Meters per second.
Probably meters per second. So that's why you're given some extra information here. The 410 kilogram boat moves the distance of 1,320 meters at 2.85 meters per second squared. What is its power? Okay. So I'll give you a couple more minutes to write the problem down. Okay, so that next formula that you had wrote down, I'll explain this in just a moment. So, does anyone see anything wrong with that equation? The equation's right, but say that again what you asked earlier. Okay? Because if you're not careful, you can write this equation like this, but if you're not paying any attention, this variable also looks like which one? Momentum. So what you can do, that's a little bit out of the frame here.
Power. P is power.
Power, baby, it equals momentum.
Okay, so power equals work over time. So what you can do, if you want, put a smiley face over the top. I don't care. You can just leave it like that if you choose, or you can put a zigzag line over top, just so you know that that variable is power and not momentum.
Is that a new formula?
It is a new formula.
What's the formula, sir? Wait, how do you label power?
Okay? Then, we label work in what?
Joules.
Okay? This one's labeled in joules. Time is labeled in what?
Seconds.
And then power is labeled in watts. Okay? So capital W for watts. Or if you want to write watts out, that's fine. I just use or choose to use a capital W.
Power's not measured in joules. What's measured in watts?
Power.
Power is.
It is?
Oh, power.
Fair enough.
Yes.
Just like force is measured in newtons.
Now, how else, if you have a really good understanding of how to utilize these formulas, how else could you write this? Maybe, because you got to be careful with that W for work as well. But what's the definition for work? How do you solve for work? You can also put this. You can also put that up there. Force times distance, because that's what work is force times distance. So sometimes I would write both formulas down. But that is entirely up to you. I mean, power equals force times distance over time, or power equals work divided by time. But please do not get the W for work confused with the capital W for watts. Those are two, one's a label, one's a variable. Does that make sense? Okay, so you've read the problem. The next thing you do is what? Okay, so what do we know in this problem?
Mass, acceleration, time, and distance.
So what's the mass?
410 kilograms.
What else?
Initial
Distance
velocity
equals
would probably be 0.
Probably.
Distance equals 1, 3, 2, 0. Acceleration equals 2.85.
Okay, is there anything else we know in that problem?
Acceleration is 2.8.
2.85 meters per second squared.
Now, some of you were talking about initial velocities or final velocities, and that's fine. But in this case, that's when you look at the label for this, that's how you know we're dealing with an acceleration. All right? So now, do we have the force yet? No, but how can you solve for the force? Mass times acceleration. Okay? So we got force equals, then you can look back at your setup rather than having to read in the problem. We got 410 times what?
Oh my gosh. 2.85.
2.8. Oh my gosh, Harry. Mike?
Okay? So what do we get when we multiply those two?
Mike. How you been, man?
Yeah, Terry right there.
1,068.50. Okay, and then this is labeled in what?
It's 168.
Oh, 160.
168. No, 1,100.
1,100.
There you go.
And what's that labeled in? Newtons. Okay, does that answer our question? No, because we haven't calculated what yet? Right? We also haven't calculated something else either.
We have to get it work.
You have to get the work done. How can that be confusing, that W? It's also watts.
Oh, yeah.
Okay? So what does work equal? What are we going to multiply that force times? Which again, you don't have to look up there. It's right here, 1320. So our work equals 1542. 420. And if there's a decimal, fine. If not, that's fine. What is work labeled in?
Joules.
Joules. Okay?
What did you say?
Now, how do we wrap this up? We still have not answered the question of power. Okay? So, how we started this was that power equals work divided by time. There's our work. So power, what you put a smiley face, a zigzag line, or you just left it alone for your variable. Whichever you feel most comfortable with is entirely up to you. We've got 1, 5, 4, 2, 4, 2, 0 divided by what?
300.
Look, 5, 1, 4.
So our power equals what?
514.
5,141.4.
And that power is labeled in what? Watts. Big W. That's why I want to put this in a different color. So therefore, that is your answer. 5,141.40 watts. All right? So, with that being said, left outside, are we good with this?
Yes, sir.
Yeah.
Okay? Middle.
Your what?
And can we presume, because she's got her, can you answer for her? Are we good with this? Okay, right side. Okay, if you tell me, you're all nodding your head yes, that you understand this. If you are struggling with this, what can you do? You can ask for help. Who has to take initiative to ask for help? Yourself. All right. So we've got some machines we're going to be looking at here on the video. So that's what we're doing for today. We will catch up to you next time.